Good morning, students. Today we are going to see about the data flow analysis, which is in your fifth unit syllabus of principles of compiler design. This is a very important analysis part to analyze the data flow in between the basic blocks and how we can optimize the code within the basic block. We need this analysis. So I will explain with an example. First, what is data flow analysis? These are the techniques that derive information about the flow of data along the program execution path. So, what is the program execution path? Suppose if you have a program instructions, first instruction may be a P1, second instruction may be a P2. So, P1 and P2 are program points. Okay, instruction points. So, the P1 between P1 and P2, what are the variables are available and what are the variable values moved to the P2 and all. Okay, so we have to analyze the data. What are the data are passed from P1 to P2? Okay, that's the P1 and P2 are program points. Okay, that is an instruction points. What are the informations or data are moved from point 1 to point 2? That kind of analysis we need to perform. Okay, an execution path or path from point P1 to point Pn is a sequence of points. So we have a program may have a different points P1, P2 up to Pn such that for each I equal to 1, 2 to n minus 1. So what is Pi? Pi is a point immediately preceding a statement and Pi1 plus a point immediately following the same statement. Suppose you have a instruction 4 line of programming. The first one is a first line of the program instruction is P1 and next line is P2, the next line is P3 and so on. So Pi is the end of the sum block and Pi plus 1 is the beginning of the successor block. Suppose in the basic blocks, the first block contains a 5 codes, means the fifth code instruction may be P5 and P6 is the next block first instruction. Can you imagine? Suppose the two basic blocks are there. In the first block 5 instructions is there, second block 5 instructions are there, so totally 10 instructions. So how many program points are there? P1 to P10. Okay, so P5 is the last program point of the first basic block. P6 is the first program point of the uh, second basic block. Okay, you may continue. So which have a link between P1 and P2 or P5 and P6. What are the data in from P5 is reaching the P6? It is our analysis. Okay, in general, there is an infinite number of paths through a program and there is no bound on the length of the path. That is, there is no bound. Okay, no analysis necessary. A perfect representation of the state. We are going to perform data analysis. What is the purpose of data flow analysis? So for program debugging, the data flow analysis is very important. So what is how far it is used in the program debugging? In the sense, in the program debugging we can find out what are the definitions or which are the definitions or variables that may reach a program point. These are the reaching definitions. What is the reaching definitions? Suppose you have a program point 1, program point 2. Suppose from program point 1, what are the variables are reaching program point 2? And from program point 2, what are the variables and definitions are reached to program point 3? So we have to analyze it. So through this analysis we can easily debug. Suppose the variable or values is not reached from P2 to P3, we can easily debug where the problem occurs. Okay, so it is called as reaching definitions. Okay, next it is mainly used for program optimizations. What are the optimizations we can carry out? Constant folding, copy propagation and common subexpression elimination. These three I have already explained in the class itself. So the constant folding and copy propagation, common subexpression is the major optimization techniques. Okay, so we are going to find out the overall design of the data flow analysis. Overall design of the data flow analysis is called as data flow analysis schema. Okay, a data flow value for a program point represents abstraction of the set of all possible program states that can be observed for that point. So it will describe what are the abstraction of that particular program points. Okay, so we have to see the reaching definition problem in following schemas: in of s and out of s. What is in of s and what is out of s? What are the values? Okay, so it is called as data flow values before and after each statement of s. So what here S indicates statement, what are the values or what are the variables are come in the statement? Yes, it denoted by in. What are the values or what are the variables came out of the statement is described by the out of S. Okay. So let's see the definition of in of S and out of S. There are, before that, there are two kind of constraints. One is based on the transfer function. What are the semantics of statements must be preserved, and second one is the based on the flow of control. Okay. So first one, see, the data flow analysis schema consists of a control flow graph, a direction of data flow, a set of data flow values, a confluence operator, which may be a union or intersection. I will tell you the later, and transfer function of each basic block. Okay. We always compute safe estimates of the data flow values. I will tell you what is the data safe estimates. Uh, let's see the reaching definition problem. We kill a definition of a variable A if between 2 points along the path there is an assignment to A. Suppose first instruction have a variable A equal to 5. In the second instruction, we are assigning the value of A. Again, A is equal to 10 means the first instruction value of A is going to be killed in the second instruction. That is, we are changing the value of A in the second instruction means we are killing the definition of variable A in the second instruction. So we can say it as kill. When we can kill the definition, the definition of the particular instruction variable value is going to be altered in the following instruction. That is going to be a kill. Okay. A definition D reaches a point P if there's a path from the point immediately following D to P such that D is not killed along that path. If the value is not altered, it is reaching the second definition means no problem. That is, program point 1 have the value A is equal to 5. P2 also have the same value of A. So what it concludes, the A value is not killed. Okay. We will see in an example. If A equal to B, if A is equal to B, A value will be assigned to 2. Else, if A equal to B, the values of A is assigned to 4. Okay. We assume that both A equal to 2 and A equal to 4 reach the point after the complete if then else statement. Even though the statement A is 4 is not reached by control flow. So what's the meaning? If A equal to B condition true means the A is equal to 2. Okay. If else if it is false only, the A value get changed. Am I right? Yes. So we will see the definitions. First, what are the definition problems? There are data flow equations. What is in of B? I already said what is in of B. So what are the definitions come inside the basic block that is called as in of B? What is out of B? What are the definitions came out of the basic block is called as out of B. So in of B initially union of P is the producer of B. So P is previous basic block. What are the previous basic block informations? Union out of P is also called as in of B. So what are the basic block? Suppose a basic block B1 have set of instructions, okay, along with the previous instructions plus out of P. That is union. What is out of B? What are the definitions generated inside the basic block? Union, what are the definitions came inside the basic block minus kill of B. So I will tell you the proper example. uh, Out of B means inside the basic block you can generate own definitions and you may accept the previous block definitions, that is in, minus what are the previous block definitions you have killed, that is getting minus. Okay. So gen of B inside the basic block your own generation union what is comes in that basic block minus what are the definitions you have killed in that basic block is called as out of B. So initially in of B is always 5. That is initially it is empty. Okay, I will tell you with an example. uh, then only you can easily. Yes, see here, this is the basic block 1, this is a basic block 2, basic block 3, basic block 4. There are 4 basic blocks. Okay, first basic block have definition D1, definition D2 and definition D3. Basic block B1 have 3 definitions, basic block 2 have 2 definitions, basic block 3 have one definition, basic block 4 have one definition. Okay, so basic block 1, here, see here,